Today we will discuss what are other type of fact tables is there, and then we'll go for the data warehousing schemas implementation. Coming to these fact tables, apart from the factless fact table, we have other three types of fact tables is there. The tables are first one is transaction fact table. Second one is periodic fact table. And third one is cumulative fact table. Okay, these are the three other types of fact tables also most of the time we can see. But actually the factless fact table is used to generally kind of forecasting and kind of for example, if you know one information, if you want to know all the group information related to that particular transaction. For example, if you know only one information about a particular product or anything, based on that information, if I want to track all the information related to that particular product or the particular transaction, then we are going to use factless fact table. But normal fact tables is there. These fact tables are going to maintain daily transactional data. Okay, because if you see in warehouse, there are two types of tables we are going to maintain. One is called dimension tables, and second one is called fact tables. In dimension table, we are going to maintain one-time business data. Here, what is the meaning of this one-time business data? Just in common example, if for example we went to one bank and we opened an account in there. When we open an account, what are the documents we submitted? Okay, what are the address we mentioned? That entire data we are going to maintain in dimension table. That's called one-time data. And next day morning onwards, we are doing some transactions. And at the time of opening an account also, we gave some minimum balance as, for example, okay, $100. That record, and the next day onwards, what are the transactions you are doing? Okay, what are the transfers or what are the withdrawals you are doing? That data is going to maintain in one table in warehouse. That is called fact table. Means always fact table will maintain the transactional data only, but dimension table will maintain the one-time business data. Okay, fact table will maintain the transactional data, dimension table will maintain the one-time business data. Here, to maintain the daily transactional data along with some measures to calculate the business values, we are having three types of fact tables there generally. One is nothing but a transaction fact table, periodic fact table, and cumulative fact table. If we are maintaining the directly what are the transactions are happen in business into one fact table, that is nothing but transaction fact table. In transaction fact table, in transaction fact table, what we are going to have is,
welcome to GoToMeeting, online meetings made easy. There are 5 other callers on the call.
We deposited some amount in a bank, and once we deposited some amount in a bank, we withdraw some amount, we transferred some amount, we did a balance inquiry. Okay, these kind of transactions, whatever it may be, whatever is happened in the business, all those transactions directly will store in one table that is called transaction fact table. Because of this transaction fact table, whatever we want to maintain in warehouse, this is bigger in size. Why? All the transactions, whatever is occur in business. For example, you change your PIN number of your ATM card, or you change your password, transaction password of your internet banking. Okay, anything. You change your PIN numbers or ATM numbers, anything. Whatever you did, any transaction, that will become a one entry in this transaction fact table. Because for every transaction there is one entry in fact table. This transaction fact table will maintain the facts also. Those are belongs to transactional activities. And the size of this transaction fact table also very bigger with comparison of other one. This size of this transaction fact table is very bigger one. And one more thing is, to maintain this transaction fact table as a ETL developer, it's very easy for us because whatever the transactions will happen in business, directly we are loading into the warehouse, right? But at the time of generating a reports by our reporting people like Cognos, MicroStrategy, Hyperion, those are different kind of reporting tools is there in data warehouse. While generating any reports by those guys, as this is a completely transactional data, but
Welcome to GoToMeeting, online meetings made easy. There are 5 other callers on the call.
load into the target. Okay, in that case of summarized data, whatever the summary whatever the summary of transactions we want to maintain, these transactional data you need to convert into summarized data, right? For example, daily we are doing transactions. I want to maintain total amount. I want to maintain average amount. I want to maintain total withdrawals and total deposits separately. Means I need to do some aggregations. Especially when it comes to transaction fact table, aggregation operations are more because the data which is available inside this transaction fact table is completely we can call as a daily transactional data only, no aggregations are happen. If you are generating a report at the time to get the summarized data, we are going to do more like a aggregation operation. Once aggregation operations are done, we are going to load the data into the target. That is about the transaction fact table. Second thing is periodic fact table is there. What is the periodic fact table? What you are doing in, means we are going to load in periodic fact table. We also going to maintain in fact table some periodic data. Periodic data in the sense, in actual business daily transactions are going to happen, but we are not going to maintain the data in warehouse fact table like a daily transaction. We are going to make like a periodical data. For example, every day at midnight 12 o'clock we are going to load the data from our transactional systems into our warehouse periodic fact table. That means there is some specific time period we are going to maintain. Whatever the transactions are happening in between the time period, those will load at a particular point of time into my fact table. That is called periodic fact table. In periodic fact table, while maintaining that kind of fact table in warehouse, we also going to make summarized data in a periodic manner. Here periodic manner means, for example, one day. We are taking one day. One day in the sense, morning to evening, what are the transactions are happened. Okay, those morning to evening, whatever the transaction may be, it may be 10 transactions or 20, whatever it may be. Those are all the transactions we are going to make as a summarized data, and we are going to load as a one record into warehouse when we are implementing the periodic factor. Because one time period we are going to take, for example, 24 hours or 12 hours. Like this, we are going to take one time period. Within the time period, what are the transactions that happen in business? So all the transactions we are going to make as summarized data and loading into targets. That's called periodic one. In periodic one, when we compare with the transaction fact table, the size of periodic table will be less, because in transaction fact table directly what are the transactions are happen in business will load. But in periodic fact table, what is going to happen? If I put 12 hours, every 12 hours it will load, but it will summarize the data. Because of what are the data is there in this 12 hours, we are going to make the data in summarization and loading the data into target. And one more thing is, when it comes to the periodic fact table, already data is loaded in day-wise aggregation. When we want to generate a monthly report, we need to do only monthly aggregation. But when it comes to transaction, we need to do so many aggregation operations to get the summarized data. But in periodic fact table, while loading the data into fact table itself, we are maintaining some set of data from 12 hours of time or 24 hours of time like this. This 12 hours or 24 hours of time, whatever it may be, these 12 hours or 24 hours of time we are going to maintain in a particular range. The range of data we are going to maintain. Next one is last type of fact table is cumulative. This is very rare cases we can see. Most of time in our products we can see either transaction fact table or periodic fact table. What is this cumulative fact table? What is the use of this cumulative fact table? Here, cumulative fact table is a fact table which is also going to maintain transactional data. Means whatever transactions are happening in a business, those are going to maintain in this table. But here it's going to maintain for lifetime of an event, it's going to maintain only one record. For example, last month I opened an insurance policy, and this month I am not interested with continue with this policy. I want to close that one. Lifetime means starting to ending of that particular policy period. Okay, we are going to maintain as a one record. In where others called cumulative means. In case of cumulative fact table, when we see the fact table data, it is very high level aggregation data. Okay, it's not going to show okay, minimum transactions or something. It's very high level aggregation data is there, and size of this particular cumulative fact table is also very less, because it's going to maintain for entire lifetime of particular transactions as a one record only. Because we are going to do those many number of aggregation operations on the data. Once those many number of aggregation operations we performed on the data, then we are loading. That's the reason the facts whatever we have in the cumulative fact table also very high level aggregated facts is there, and the size of that particular fact table also very less with comparison of transaction and periodic. And in the cumulative fact table, the dimension tables.
Welcome to GoToMeeting, online meetings made easy. There are 5 other callers on the call.
Record only. For example, in the year of 2007, I opened an account. I close account in the year of 2012. In between, there are normal years is there and leap years also there, right? That's what. Okay, to maintain these fact tables surrounded by n number of dimension tables is there. What in the dimension tables also? What are the date dimension table? Especially in the date dimension table, it is completely going to maintain the information about all these transactions, whatever it may be. Okay, this is going to maintain a cumulative category. That is about the cumulative fact table and periodic fact table and transaction fact table. These are the 3 types of fact tables is there while implementing warehouse. Okay, just a second. Generally, when we are implementing any warehousing process with these fact tables, we are going to maintain any of these fact tables depend upon our business requirements. And one more thing is, while implementing these fact tables, we are going to maintain the fact table data and corresponding dimension table data. As the dimension table data is the primary data there, and fact table data is like kind of foreign keys data, which we are going to maintain. Before implementing the dimension tables in warehouse, first we need to create the corresponding fact dimension table. Before implementing the fact tables in warehouse, we need to create a dimension table source, because those are primary tables. Once we load the data into dimension tables, then we can load the data into corresponding fact tables. Right? That is about the dimension tables, facts, and fact table types. These all the things will come under logical data modeling. Especially under logical data modeling also, sub modeling that is called dimensional data modeling. Once this is done, last type of modeling is actually physical data modeling. What our data modeling team will do in case of physical data modeling means, in physical data modeling, our data modeling team will try to identify what are the we simply call as a what are the physical implementations we want to do. Simply physical implementations in sense, what are the primary key columns we want to decide in a particular tables, what are the type of indexes we want to build on those tables, and physically creating those tables on database level by DB team. All the things are going to happen in physical data modeling. Means the main part of the modeling is logical only, because in the logical data modeling, first we are going to draw ER diagrams, then we'll go for the dimensional modeling also. In dimensional data modeling, we'll try to identify dimension tables, fact tables, and facts also. Okay, this is about the modeling. In this modeling, when modeling people are identifying the dimension tables, because you don't need to worry about as a developer for identifying the dimension tables and fact tables. Already modeling team will identify what are the dimension tables is there in our project, what are the fact tables is there, what are the facts is there, and in dimension tables also what are the different type of dimension tables is there. All the things they will identify, and they will give a kind of documents. Just let me show you what are the documents every day I am showing you. The documents are the documents which are they are going to create after implementing the physical data modeling. Means once the physical data modeling is finalized, they are going to prepare this kind of document and they are going to share this kind of documents to us. See, these are physical data modeling documents. Physical data modeling okay, means once we know all the kinds of dimension tables and fact tables information, then we'll go for this kind of structure they are going to create. Here is the fact table. Q account error is the one of the fact table. Surrounded by this particular fact table, we have a number of dimension tables there. See, this is one dimension table, one dimension table, one dimension table, one. Like this, multiple dimension tables are having a relationship with that particular fact table. And here, it's also one more fact table is there. This is fact table also surrounded by a number of dimension tables. These all are dimension tables. Okay. Like this, what are the dimension tables is there, or what are the fact tables is there? They will draw this kind of diagrams finally once they identify dimension tables, fact tables, and facts. This kind of diagram they are going to give to ETL developer. As a ETL developer, you need to understand what are the dimension tables is there, what are the fact tables is there, what is the relationship between dimension table to fact table, and what is the primary key columns is there in dimension table, how those primary key columns are related to corresponding fact table. Then based on that, and we are implementing any ETL process, we can understand easily how to implement a particular data in the dimension table also. Okay, this is about the dimension table and fact tables and facts also. Right. Next, we have one more concept that is we also need to know. Once implementing the data warehouse, we can also identify that. Just a second. See here. Once we implemented this kind of data warehouse, this is a warehouse actually. These are called front-end systems. We are going to get the front-end upstream systems. Every day we are going to get the data from these systems and doing the ETL operations here, then finally loading the data into warehouse. Once the data is ready in warehouse, we are also going to maintain the data in separate system. Those are nothing but a data marts and operational data stores also. ODS is there and data marts also there. What is this data mart? What is the use of this data mart? Do we need to maintain this data marts also mandatory while implementing any warehouse? It's not mandatory to maintain the data marts in any warehouse implementation, but if required, we can maintain. Just let me explain what is the meaning of data mart. A data mart is a subject-oriented subset of a data warehouse. Okay, it's simply called as a small piece of data warehouse. Whatever the data marts we are implementing, the data marts, whatever it may be, that data marts we can simply identify, and the data marts we can simply useful for directly which are okay reporting purpose. Especially we can create the data marts along with one subject area data that will be useful for creating a reports in a business. Very simple definition for data mart. Okay, let me again repeat the definition. A data mart is a subject-oriented subset of a warehouse. If you observe the data in warehouse, it is going to have multiple subject areas data: customer subject area, loan subject area, credit card subject area, insurance subject area, investment subject area, okay, wealth management subject area, healthcare process subject. Like this, multiple subject areas is there, right? What are the subject areas data we are maintaining in enterprise data warehouse that we are going to split into multiple data marts? Each data mart is going to maintain one single subject area data. For example, we have customer. All the customer data, whatever we have in warehouse, we are going to maintain separate machine. That is called data mart. What is the use of this data mart? Is there any advantages by implementing this data mart? Yes, few advantages also there while creating this data mart. One is maintenance of data marts are very low cost with comparison of the data warehouse data maintenance. And one more thing is, if you are maintaining the biggest database system, that is data warehouse, we can control locally rather than centrally. Okay, we can simply control locally, and we can also, instead of maintaining global, means if it is a biggest data warehouse system that you need to maintain globally. Instead of maintaining global, it's better to control centrally. Why we are going to control central means data marts are going to maintain only one single subject area data. And when we compare the data wise, always data marts are having lesser in size, with comparison of data warehouse. And what are the data we have in data marts, which is having only one particular subject area data. That is the reason it is also going to provide rapid response. Like this, few features also there and few advantages also there. What are those advantages? Means limited speed of data. It also going to provide single subject areas with a few dimensional tables will be there. Quick response will come. It will also quick impact on bottom line problems of the business. It directly focuses the needs of users. Like this, there are some advantages there. And apart from advantages of creating data marts in any warehouse, few disadvantages also we have. But when we compare with the disadvantages, advantages are more. That's what we are creating marts in any of the warehouse implementation, apart from creating tables. Right, what is this disadvantage of the marts? It does not, the disadvantage of marts are nothing but it does not provide integrated view of business information. It does not provide integrated view of business information here. What is this integrated view of business information? If you see one single data mart, it completely going to maintain that particular business unit information only. Just for example, we are having a loan data mart. In the loan data mart, what kind of data we are going to have? Only loan related transactional data. Corresponding fact table and dimension table will be there, but only loan data will be there. For example, I want to know for a particular customer what are the loan account is there and what are the credit card account is there and other relationship with the same customer. Means a customer may have a credit card in the same bank, savings account in the same bank and loan in the same bank, maybe insurance policy also. I want to know total information about that customer. Is it possible by looking the data into only one particular data mart, can we give the integrated information about that particular customer? No. And in case number of marts also increase, then automatically there will be redundancy will come in data. Means uncontrolled proliferation of data mart may result in redundancy. There will be redundancy will come into this one. That is also one drawback. And more number of data marts whenever we are implementing, it will also complex to maintain. When we are implementing the more number of data marts, these data marts are also complex to maintain. And sometimes what are the scalability issues? What are the scalability issues there is there? Like scalability issues in the sense, if large number of users are accessing the same data marts also, automatically the performance of data mart also will reduce. But these are common disadvantages only. Along with the disadvantage, we have more advantages there. That is the reason most of products we can see when you are implementing either top-down approach or bottom-up approach, data marts also will be there. Right. What are the different types of data marts there while implementing a warehouse? Depend upon the approach what we are following while implementing warehouse, these data marts are there. What are those means? Embedded data marts, dependent data marts, independent data marts. What is this embedded data marts? What is this dependent data marts? What is this independent data marts? Here embedded data marts are the data marts that are stored within a centralized data warehouse. If those are the marts which are maintained within a data warehouse itself, that simply we can call as a embedded data marts. When we can see this kind of embedded data marts means if you are implementing a centralized data warehouse, marts also inside the data warehouse itself, there is no separate system. then we can call that is a embedded data marts. And while implementing top-down approach, if you remember, when we discuss about the top-down approach process, once the warehouse data is loaded, we are going to load the data into the marts. That's called dependent data marts. The marts which we are creating in top-down approach, after creating the data warehouse, okay, then we are going to create separate system that is nothing but a dependent data marts. These dependent data marts are fed directly by the data warehouse, and sometimes we are also going to get the data from some external applications also. And next, third type of data marts are nothing but independent data marts. These independent data marts are the data marts that are fed directly from external applications, and those will not use the data warehouse data, because in the bottom up approach, these kind of marts are going to be created before loading the data into the warehouse, right? These are the different type of marts is there. If you observe in this project architecture, what I showed you just now, we have marts is there. These marts, okay, if you see here separately, these marts are okay maintained separate systems. These are dependent data marts. Once we load the data from source to this staging area and staging area to warehouse, and warehouse to we are going to create separate systems called marts. Okay, these marts whatever we are going to create is nothing but a, we simply call whatever we have or whatever the marts we are implementing is nothing but dependent, because these marts whatever we created here are completely dependent upon warehouse. Once the warehouse is created, the data whatever we have inside a warehouse, that data we are going to create into, or we are loading into marts. This is about the data marts. Okay. What is the use means, once these marts are ready, whenever any reporting people want to generate any report, they will not interact with the data warehouse database. They will directly contact these data marts systems, and they will get the data which is required for generating the reports. That's the use of marts. Right. That is about the data marts and everything. Next is ODS is there. What is the meaning of this ODS? That's called operational data store is there. What is the meaning of this operational data store? What type of data we are going to maintain in operational data store? Here, operational data store is nothing but it's also a kind of subsystem while implementing a warehouse, and in the process of implementing a warehouse and marts data. But what type of data generally we are going to maintain in ODS means, once operations are done in staging area or in front end or in landing area, then we are going to load the data in one system that's called ODS, operational data store. Generally, what is the use of this particular operational data store means, sometimes before loading the data into warehouse, we want to maintain the data sometimes, okay, up to 90 days or up to 120 days in somewhere before processing the data into warehouse. That's called ODS generally. Or sometimes in some products we can also see ODSs we are going to create after implementing warehouse also. These ODSs also directly will be useful for generating the reports actually. Just let me show you what is the basic difference between ODS and data warehouse data means. ODSs will have the daily data or lifetime frequency data, but okay, warehouse is going to have huge amount of data, and this is going to maintain these ODS systems whatever we are separately maintaining. Okay, will maintain the data between mostly 30 to 90 days of data, but it is going to maintain infinite. There is no time limit to maintain the data in warehouse. And what is the data we have in ODS that is directly useful for generating or for operational needs means, whatever the data we have in ODS, that data will be useful for doing kind of operations on operational purpose of the business. But what the data which is there in warehouse, that is used to make address strategic means, which is used to address the strategic decisions of the business. See, if you see the difference between OLTP means front end, ODS and warehouse. Okay, from particular points wise, if we see the data redundancy wise, what are the data we have in OLTP means front end system, there is no redundancy, or okay, non-redundant system or within system itself, or sometimes unmanaged redundancy among the systems also. And here somewhat redundancy with operational database. Here this is completely what are the data we have in warehouse. That is completely we have redundancy data, but that is also managed redundancy will be there. There is no unwanted redundancy, or there is no unmanaged redundancy will be there in warehouse. There is a major difference between OLTP and ODS and warehouse. And stability wise, these OLTP systems are dynamic, because if any customer changes his address, then that needs to be updated into OLTP, right? What are the changes we are doing? Those changes we need to maintain. That's called dynamic data will be there. Here somewhat dynamic, this is static. What are the data we load into warehouse? That is not completely static or something. We can call that is static, but few of the data is also going to be updated. And data update wise, it is going to update field by field. Here in ODS also we are going to update field by field, but generally in warehouse means we are going to have huge amount of data. To update the huge amount of data, we are going to write some ad hoc queries. Those queries will load the data, or we are update the data in those database tables. And usage wise, data usage wise means OLTP has a highly structured representative. When we go for the ODSs, we have somewhat structured is there, somewhat the data is analytical data. But when it comes to the warehouse systems, we have highly unstructured, heuristic or analytical data. Mostly the data which is there in warehouse, it may be unstructured also, but it will be useful for analytical data. While maintaining the data, we are going to make the data as a summarized data. Because of there is a summarized data here, it simply maintains analytical data that whatever the analytical data we are maintaining, that is useful for the business analysis, and that is useful for the business decision making process also. And database size wise, if you see, OLTP and ODS are normal in size. That's called moderate in size, but when it comes to warehouse, it's a very, very bigger in size. And database structure wise means OLTP is stable and ODS is also stable, and data warehouse is dynamic, because structure wise means when data is inserting, when the data is inserting into the data warehouse system, automatically the size of data warehouse tables will be increased. That's what we can call as a dynamic in size between warehouse systems to ODS, right? There the difference is there. These ODS are also not mandated to maintain in warehouse. If required, you can maintain as per the architecture. If there is no need, then we not need to maintain that. This is about the operational data store and data warehouse system. And one more thing is, we also have a data marts, those things, and other things also, fact cancellation, other thing also. Here, apart from these dimension tables, fact tables, data marts, and operational data stores, next we have one more concept that is called data warehousing schema implementations. Means to implement a data warehouse, we need a different type of schemas in there. What are those different type of schemas? While we want to implement any data warehouse, generally we are going to use two different type of schemas in there. One is star schema data warehouse implementation. Second one is snowflake schema data warehouse implementation. Right? They are the two schemas. Sometimes in some projects we can also see combination of both in a single project also. Combination of the star and snowflake also we can identify in single project. Right? What is the meaning of star schema? As a ETL developer, do we create this star schema? No, we are not creating the star schema. Once the structure of the schema is designed by data modeling people, in the same way we are also going to load the data into the data warehouse tables, first into dimension table, then into the fact tables. What is going to happen in star schema data warehouse implementation? For example, assume that we have one schema. If this is a centralized fact table and number of dimension tables is there, can I call this star means? It looks like a star, but actually in database it's not a star. What is this? Star schema data warehouse data is going to maintain this. In star schema data warehouse implementation, we have at least one fact table surrounded by n number of dimension tables. We have at least one fact table is there surrounded by n number of dimension tables. what is that fact table we have here? That particular fact table is going to maintain the denormalized data. What are the data we have in the fact table is completely denormalized data, and the data which is there in dimension table we are going to follow normalized data. Okay, we'll also explain in next session that is what is this normalization, what is the meaning of first normal form, second normal form, third normal form, those things also. Here fact table is going to maintain denormalized data and dimension tables are going to maintain normalized data. Because the fact table is maintains a denormalized data, but dimension tables are maintained the normalized data which are surrounded by this particular fact table. This entire star schema we simply going to call as a denormalized schema, and the data which is there inside the dimension tables, because of there is a primary key data, all the key columns which are there in these dimension tables are going to have a direct relationship with the fact table. See, if we have, this is the dimension table. Here in this dimension table we have a time key. This is having a direct communication with the fact table, and branch key is there, that's also having direct communication. Item key is there, that's also having direct communication. Location key is there, that's also having direct communication. Okay, these fact tables whatever we are having, these fact tables surrounded by dimension tables, whatever the dimension table we are implementing, these dimension table will have direct communication with the fact table. Because of all the dimension tables have a direct communication with the fact table, there is a primary to foreign key relationship is going to be established between dimension table to fact table. Okay, if you implement this kind of structured schema in any warehouse, that is called star schema database implementation. Okay, in star schema, there is no indirect communications, and one more thing is entire data, because of fact tables are maintained normalized, denormalized data, we are going to call entire star schema and a denormalized schema, and the tables which are there surrounded by that particular fact table, the dimension tables is okay, have a direct communication with all the fact tables, there is no indirect communication, and these are also going to maintain normalized data by applying different kind of normalization rules. That is simple definition of star schema actually, but we'll also discuss one project example how we are going to implement star schema in our project. Okay, in tomorrow's session we are going to discuss about the star schema and snowflake schema. I need to discuss with the batch people because they're also having a little bit issues. Tomorrow I'll ask them to come at later 10 minutes after. Then we can also extend our time to up to 7:45 my time. Any questions here? Okay, fine then. If there is no question, then we are good today. We'll meet tomorrow and we'll discuss the rest of schemas in tomorrow. Once the schemas is done, means our basics part is done. Our data warehousing basics are done. Once our data warehousing basics are completed, then we'll go for ETL basics. And ETL basics are done, we can start the Datastage tool. Okay, once between these days, if you are all guys are confirmed, then we are also going to install software into our missions. Okay, fine then. We'll meet tomorrow and we'll discuss it. If you have any questions, we can talk on tomorrow. Thanks. Okay.